Broadcast is now starting. All attendees are in listen-only mode.
Good morning, everybody. Welcome to episode 273 of the Db2Night show. Today, we have a very important and timely topic, Db2 12.1 security update from lab. Security has never been more critical than today. Db2 continues to evolve with cutting-edge feature to protect enterprise data while ensuring compliance with security standards. We are very fortunate to have with us Greg, Db2 Security Architect from IBM Canada Lab. Greg has been deeply involved in the design and implementation of Db2's advanced security features mechanism, and today he will be sharing insight into latest improvements in Db2 12.1.2. Greg, thank you very much for joining.
Oh, thank you for having me, Mohit.
Oh, welcome. Thank you. Get involved. This is your show, so please do follow us on X as well as the YouTube channel. So the links are provided here, and also the LinkedIn group. Disclaimer. Tonight's show, we have Db2 12.1.2 security update, including the restricted file permissions and alternative masking semantics. We do have multiple other sessions coming in the recent months. September 12th, we have unlocking recovery. Michael is going to come back again, and then we have AI optimizer, BYOC, Azure, Db2 AI Vector, and then Intelligence Center, which is the new monitoring solution for Db2, which replaces DMC. Lineup, we have great sessions lined up for the coming months. Register as and when the links are out. The DB2Night show, sponsored by DBI. It provides you greater reliability, faster and efficient SQL statement query tuning for Db2 SQL Server. Please do visit this link, demo.php, where you can look at the product features and the working nature of the product. So that'll give you much insight into how product works. Thanks to our sponsor, DBI, smarter tools for smarter people. You will have a couple of polling questions on your screen coming. All right, so what Db2 LEW version you're running? Good to see people running 12.1 in production or in the environment. Awesome. Collecting the responses, closing the poll, and sharing the result. So we have about 33%, 12.1. That's great. About 100%, everybody using one or the other instance with 11.5.8, 11.9, and 11.1, 33%. Please do visit our previous webinars where we will have a lot of discussion about what 12.1 feature provides you and then what feature you can make use of. Are you running PureScale? Okay, collecting the responses. Closing the poll, sharing the results. It's a no. We did cover one of the PureScale with pacemaker session. Toby took it. That's going to be one of the fantastic show you can look at. And also performance benefit, what you're going to gain from PureScale. Take a look at that webinar as well. Okay, what are your environment challenges for Db2? All right, collecting the responses. Closing the poll, sharing the results. Interesting this time. no performance problems or availability issues, resiliency and data growth. Yeah, I think we have a couple of sessions for resiliency and availability as well. Michael is going to come back on that. Data growth, that's interesting topic to work through. Are you running pacemaker in production with TSA, with HADR or PureScale? Okay, collecting the responses. Closing the poll, showing the results. Yeah, lots on TSA and then no plans to convert. All right. One last polling question. Are you using DB2 masking feature? Okay, collecting the responses. Closing the poll, sharing the results. 33% yes and 67% no. Okay. We'll get to hear a lot of things about the masking and alternatives in this session. Please do feel free to put the question in the chat section. I can provide that back to Greg. Okay. All right. Moving on. DB2Night. Sorry. DB2Night show episode 273. Db2 12.1.2 security update from Greg, directly from IBM Canada Lab. Greg worked, on most of the features within Db2 security and encryption, auditing, and authorizations. And great to have you here. And Greg, I'm going to make you as a presenter.
Okay, great.
You will see a pop-up coming.
Yep.
I can see the screen.
Okay, and did you see it change? Yeah, we saw it change. Perfect.
I did, yeah.
Okay. Can I get started then?
Take it away, yeah. Thank you.
Perfect. Thank you very much, Mohan. And thank you everybody for coming and listening to this. Version 12 was such a big update that I'd actually like to take a few minutes to go over kind of everything that's happened as of version 12.1. We're going to get to the 12.1.2 updates, but there's just such a big change in version 12 that there's a lot of things I think it's good for everybody to know about. And the reason for that is that, there's especially for security, unfortunately, we need to make some breaking changes over time as things become insecure, that they shouldn't be used, that we do want to get rid of them so they're not, accidentally used, that sort of thing. And the major release is really the time to do that, right? That most people spend more time reading the documentation, understanding what's new, and that's the time when we like to make those unfortunate breaking type changes. So presentation is going to go through new features, but also changes and discontinuations. We'll go pretty quick through the version 12 stuff so that we do have lots of time for the mod 2 updates. So the new security features, the new stuff that's in 12.1. A pre-instance upgrade check. So a lot of the things, I shouldn't say a lot, but there's several things that are breaking changes that we've discontinued certain features that have no migration path. And it's a pretty bad customer experience to, get some downtime to do the upgrade, all of a sudden to have it fail because something went wrong. So we've updated DB2 Check Upgrade to not only be a database checking tool, but also an instance checking tool, that it will look for certain things to tell you that you need to change them before you can do the upgrade. DBAtom can manage table spaces now in buffer pools. We've heard that request a lot, that, you know, our security model is that sysatom or syscontrol should be able to control instance-wide or machine resource settings that are outside of the database. So things like memory, disk, etc. But that the sysatom can delegate to a database user like a DBAtom as appropriate. So starting in version 12, excuse me, DBAtoms can now create automatic storage table spaces inside storage groups that the sysatom has created. So the sysatom, you know, saying, okay, here's the automatic storage, the storage group that you can use, and DBAtoms now can make use of that instead of always requiring a sysatom to create those table spaces. Similarly, buffer pools. We now allow a DBAtom to create buffer pools up to the database memory limit that the sysatom has set. So, you know, we're pushing things down into the database so that you can get that sort of easier management. You don't have to be giving out such high-level privileges. To take it even farther, in Mod 1, we've introduced a new authority called the Tablespace Admin Authority. And that is now so that, you know, taking it a step further, you don't even have to give out DBAtom privilege. You can now grant tablespace atom privilege on a storage group, and that will allow that user to create those automatic storage table spaces, right? And to grant use privilege on those table spaces, and also to run the table space monitoring routines. So again, it's pushing down some new privileges so that you don't always need to be granting high-level privileges to, say, an application team in order to manage some of these resources. We've also created a new use privilege on buffer pools for the similar scenario, so that you can now grant that to people to use rather than having to have a high-level authority. Okay, a big new feature in 12.1 is limiting audit for an application. So this is a challenge. We had a customer present to us that you know, applications can generate huge amounts of audit data when everything is audited. Anybody that's turned on audit in DB2, I think, has experienced that because there's just so much that can happen. But your application may have its own auditing, and it kind of creates a duplication, right? Now you're getting the same sort of audit records from two different places. And is there a secure method of eliminating auditing within DB2 for connections originating from the application? So not just turning off audit, but only turning it off for connections from an application. So the challenge is, well, how do we identify the application? How do we control audit to turn it off? So this is what we've come up with. So we have created audit exceptions for a trusted context as the control mechanism to turn auditing off. And we've created a trust procedure mechanism, which is a custom sort of procedure to help define an attribute of trust, taking it sort of to a much more custom level about who defines a trusted context. And then there's also the notion of an application identification token to help securely identify a custom application. So the audit exceptions are sort of pretty simple to understand. You just add an exception for a trusted context and you give us the name. You know, the way we normally control what gets audited is we gather up all of the different things that you have audited, right? You could audit a person, the database, an authority, a role, all the sort of things get gathered up when a user connects in a union type manner. And that's your sort of effective audit policy for that connection. However, the audit exception at the global level that we've introduced sort of overrides that and can shut the audit off within that trusted context. Currently, we only have the trusted context that can take an exception. You know, we're open to hear business use cases for other objects that might have an exception, but in version 12 right now, it's just the one type for trusted context. But it basically turns it off. So when that trusted context, when you establish that trusted connection, then you won't be audited within it. The trust procedure is sort of modeled after the connect proc. If you're familiar with that, it's a stored procedure that can run for every connection. This is very similar. It is a procedure that will run if you are establishing a trusted connection. So now the application will need to say, hey, I'd like to establish trusted connection, and it's going to run this trust procedure. And some of the benefits of that is currently you can only have 2 attributes right now that define whether something is trusted. And it's basically what is the IP address that it is originating from, and you have to tell us individual IP addresses one by one, and the other is whether there's encryption. High basically being is TLS being used. And that's the only attributes that can define whether the connection is trusted or not. Well, this stored procedure now allows you to create your own custom logic that can define trust. So and this can be used outside of the concept of audit exceptions. This is just sort of a standalone feature, and it's part of the bigger picture, but by itself it can be used, right? If you wanted a range of IP addresses, you didn't want to type them in one by one, you could easily add that into the stored procedure. You could take more complex logic, perhaps the time of day you want to take into account, something like that, right? And those can now, you don't have to try and ask us to say, well, can you add this feature? Can you add that feature to determine what is trusted? You can encode those in your own custom stored procedure. And they'll have access to the application ID token to validate as well. So it's pretty simple to use. Just this is the syntax diagram for the create trusted context statement. You would just specify a trust procedure to call. You can put it in combination with the other parameters or not, it's up to you. So the app token, this is the part where we said, how do we securely identify the application that is coming in? It's not an easy task to sort of remotely see who the application is, because you don't want, say, someone connecting from the CLP from that same machine to have auditing turned off. It's only within the trusted application, right? So what this is this app token is a binary token that the application will generate. So it's not generated by Db2, it's generated by the application. Db2 doesn't really know what it is. It just knows it's binary data that we will transport from the client application into the Db2 server, where that trust procedure can validate it, okay? You might have something like the application has access to a certificate that it's going to digitally sign certain aspects of the connection that it can then send over and have the trust procedure validated. So we're really pushing this out to the application for it to determine exactly what is the nature of trust to establish that trusted connection. This is, an optional part. Again, to use the audit exceptions, you just need to establish a trusted connection. It can be with the trust procedure, or it cannot, and it can also be with the app token or not. Like, they're all sort of independent pieces, but you can put them all together to get the most secure usage. There's a nonce that we generate during the connection handshake that becomes or can become part of that application token. I'll quickly demonstrate in a minute what that looks like. And there's also some user data that can be provided from the application as input. So we kind of have this diagram here of how the flow works. So on the left-hand side, we have our application, and on the right-hand side, we have the DB2 engine. And in this case, we're looking at like a CLI-based connection. So the first step is the application can provide any connection-specific details that it wants to be used as part of this, as part of the app token. Okay, so it sets those within the CLI driver through this API. It then calls connect to the database, in the standard methods. So we start the connection. Now this is all happening as part of the handshake, okay? DB2, the engine will generate a nonce and will return that back to the application. The CLI driver will call a callback within the application. So you can register a callback to say, hey, here's the function that needs to be called to generate the app token. Okay, that generates the app token. So this is sort of outside of DB2. This is the application inside the callback. Generating the app token, returns that to the CLI driver, which sends it to the DB2 server, which makes it available along with the nonce to the trust procedure. That nonce is basically so that this app token is unique to this connection, so that you're not generating a token that could be reused somewhere else. If someone were to happen to be able to sniff the network and see that app token, they wouldn't be able to reuse it on a different connection because it would be a different nonce. Those are random and unique to every connection. So the nonce and app token are provided to the trust procedure, which decides whether this connection is to be trusted. It returns a special SQL state that says, yes, I explicitly trust this connection, which is returned then back to the application, the CLI driver, saying you're connected and you're trusted. So it's quite a handshake there. There's a lot of moving pieces, but it's really that extra step to say we know exactly who the application is now, and they can be trusted. So this is, authentication hasn't even occurred at this point yet. We don't know who the user is to DB2 yet, but this is just identifying that the application is trusted. So the couple global variables, the app token nonce and the actual app token, that's how they are provided back on this diagram to the trust procedures through some global variables. And they are only available to that trust procedure because they can contain sensitive information like the app token. They're only available to that trust procedure and not to the general connection after that. So you put all of those together and you can get a secure method of disabling audit for that application. Okay, another mention of a feature we've introduced is support for seccomp, or secure computing, which is a Linux kernel facility that can limit what OS system calls a process can make. And this is really for sandboxing the fence mode process. For running user code, it's off by default, but it can be enabled with a configuration file here that tells us what system calls we should allow. So there's a default set that DB2 always allows just in order to call a fence stored procedure, to call Java, that sort of thing. And then any other system calls are blocked by default. And this can just help prevent any security problems if maybe the stored procedure code you're running isn't as trusted as you'd like it to be, or has potential bugs, is doing something networking related that might expose it to the outside world, and you'd like to help lock it down. This can be a benefit. Tenant authorities, tenant was introduced in version 12, and there's a number of authorities that are associated with it. Basically modeled after the schema authorities that we have now in DB2. So things like select in, right? So it used to be select in on a schema, so you could select from any table in a schema. Now there's also a select in on the tenant, which allows you to select from any table within that tenant, regardless of what schema it is. And similarly for insert in, drop in, that sort of thing. And there's also authorities over that tenant. So access control, data access, load, and tenant atom being similar to a DB atom at the database, but for the tenant level. So helping you, again, provide some control over inside that tenant, but without having to grant authorities over the whole database. Some very small, just miscellaneous item ones that, I think in the interest of time, come back, pause here, and can read about these later. Okay, behavior changes. So these are changes in default behavior that everyone should be aware of. In version 11, when you granted DB2, so if you just said grant DB2 to user Greg, you also got data access and access control under the covers. This goes back to when we introduced data access and access control in SecAtom. We wanted the DB2 to have the same level of authorities they did in much earlier versions of DB2, like version 8. And that meant having data access and access control. But not everybody realized that they were getting these additional privileges by default. You could always ask to not get them, so it wasn't mandatory, but you had to type that out. And now we're basically switching it so that when you say grant DB2, that's all you're getting. You do not get data access or access control. Again, the syntax is there so that you can, but by default, we're changing that default behavior so that you only get what you asked for. If this really breaks, say, an application that you have no control over, we do have a registry variable that will revert the behavior. You know, we understand that there may be an application that you can't change that expects the old behavior, so it can be re-enabled, but by default it has changed. Similar, public no longer is granted a number of privileges during create database. So when you create a database in version 12, public will not have connect privilege. This is probably the most impactful one, that you need to now go and explicitly say who can connect to the database. But there's others. Create tab, implicit schema. Everybody was always able to make use of those. They really shouldn't be able to, and now as of version 12 they can't. Once again, there is a registry variable to revert the behavior if it's really not desired, and you don't have an option of, changing it yourself. You can always go in and grant, again, connect to public if you want it, but maybe you have an application that's actually creating the database and setting everything up, and it breaks because of these changes. It can be reverted. I should say for both the previous one, for the DB2 and this one, they're only changes when you issue the statement. So when you issued grant DB2, or in this case, create database, that are affected, we are not going into the catalogs and changing what was already there. So if you're upgrading from version 11 to version 12, we're not going to go and revoke public, the connect from public. It's still going to be there. This is only when creating a new database or granting a new DB2. Okay. Hostname validation is on by default. This is a change that can break connections, so it's really important to point out. Hostname validation is a feature that was added in 11.5.6, but it was off by default. And it is a feature when using TLS or SSL to validate the host name that the client is connecting to matches what is in the certificate at the server. Depending on how you set up your certificates at the server, there's a reasonable chance that they haven't been set up correctly to contain the host name, okay? And that as soon as you move to a version 12 client, those connections will fail. So it's really good to know that this can happen. You can turn it off if it breaks. That you can go, there's client-side configurations, the same way it was turned on in 11.5.6, you can turn it off as well. Recommendation is that you recreate your certificates for the server so that they actually have the host name as part of them, just because it's a lot more secure for the client to be validating that matches. There's a number of places where it is used, just to be aware of. So it's not just client-server connections, but it's also HADR between the primary and the standby, outbound federation connections, and native encryption connections to a KMIP server. So we have really good documentation on how to set this up and what your certificates need to look like for all sorts of different scenarios. So consult the docs there. And the other thing you can do is you can check right now. You can turn this on in version 11.5 and just connect to your server on a separate client, right? You don't have to do this on your production client because it is a client-side check. You can do this on, just get something on your laptop and try connecting to see that it's going to work or not. And this just shows you here, it's the subject alternate name that you need to have set up with the host name to turn on. So you can look for that now just to see if you're ready for version 12. FIPS 140-3 related changes. So FIPS 140-3 is a US government standard for the security requirements and validation for cryptographic modules. So it's generally mandatory for US federal agencies to follow, but is often used as just a reference point by international organizations. And we're asked about it from sort of all over the world. So it's not just a US thing, although that's where it's most popular. So it's basically, how does the code that is doing the cryptography, how does it work and respond to errors, that sort of thing. So DB2 uses a library called GSKit to do the cryptography. It's used actually by many IBM products. It's in sort of an internal component. Previously, it was certified to FIPS 140-2 and is currently under evaluation for version 3, which is just as of the last year or so, the most recent version of FIPS. The current version, what V12 mod 2 ships with, is not the version 3 certified level yet, but all of the breaking changes that we knew were going to happen, we wanted to enforce in version 12 GA, just so that we weren't having to make those sort of changes in a mod pack, right? That it was a major release that enforced some of this in anticipation that as soon as we have the latest version of GSKit, that we can ship it. So we now have 3 FIPS mode that you can configure. There's strict FIPS, FIPS, and no FIPS. There's a registry variable, DB2 auth, that can specify it. If you set nothing, the default is FIPS mode. Otherwise, you can turn on strict FIPS or no FIPS. And we're going to go through what each of those means. Certain platforms, like all the 32-bit platforms and right now Mac OS, do not have FIPS support. Basically, DB2 ships 2 versions of the crypto library, one that was compiled and has been tested by the US government that has FIPS support, and one that does not. It's the same code base, basically, except the non-FIPS version is more up-to-date, has the sort of latest functionality in it that has not necessarily been gone through that government testing. These FIPS modes are for CLI and CLP based clients and the DB2 engine. Java, outside of the JDBC driver at like the Java level, has its own FIPS settings that sort of Java controls that aren't related to what we're discussing here. Strict FIPS mode was actually introduced in 11.5.9 and 11.5.8 CSB, but it's been really enhanced in version 12. And what we're stating with this is the really strict adherence to the standard over available functionality. So certain functionality, like we see a list here, is not supported when you turn on strict FIPS mode. So this is, you're telling DB2, hey, I absolutely need to adhere to 100% of the standard. Please work that way. So certain things, functionality in DB2 is just not available because, and we'll go through the reasons, it's usually just because it's so old and using sort of unsupported algorithms. FIPS mode is our attempt to be as secure as possible and follow the standard where we can, but it's really about the spirit of the law rather than the letter of the law. That, you know, there's been cases where there's been security vulnerabilities that have only been available in the non-FIPS mode of GSKit that we would prefer to get out there. And so FIPS mode says, yes, we're able to sort of, you know, in the spirit of the law, use FIPS wherever we can, but in order to solve this one security vulnerability, we're going to, in that one case, use the non-FIPS version for that functionality, okay? Whereas strict FIPS mode says, nope, just, you know, disable the functionality if it has to be, rather than use a non-FIPS version. Okay, so FIPS is kind of this middle ground of best effort. It also allows us to use widely accepted algorithms that strictly are non-FIPS, such as Cha-Cha, which is an encryption algorithm that is very popular, widely used. So we'll consider the use of it here. Non-FIPS is basically don't use the FIPS certified version at all. You know, pick up the non-FIPS, which has the least restrictions and the most functionality available to it. Some of the other behavior changes, RSA cipher suites for key exchange are no longer allowed. This is only really an issue if you were telling DB2 explicitly to use certain cipher suites in TLS, that this is no longer allowed. So by default, DB2 is going to negotiate the strongest one and won't be using this, right? But in case you explicitly had specified it, it's not allowed under FIPS mode, okay? Cha-Cha, as I mentioned, as an encryption algorithm, and X25519 and 448 are elliptic curves for key exchange. Under FIPS and no FIPS, those can be used, and but not used under strict FIPS because they're simply not supported by the US government. And you can see here whether they are enabled by default or have to be actually configured. So it depends on that FIPS setting. Extended master secret is just an additional feature in TLS about how it computes the master secret between client and server. It's just natively part of FIPS, part of TLS 1.3, but in TLS 1.2 it was optional. And there was ways of saying whether it was mandatory or optional, or just it wasn't present. And basically in 11.5.9 C clients, it was not sent, it's not available. And if you have strict FIPS mode enabled on a version 12 server, those down-level clients won't be able to connect because the C clients don't have the concept of the extended master secret. The Java clients do send it, so it's there. So just to be aware of that, one of those things about enabling strict FIPS mode is that there's some of these features just don't work. If you're using TLS 1.3, which is supported in 11.5.9, then this will just work fine, right? That both sides support TLS 1.3, which has the extended master secret just as part of it, and your connections will work. Similarly, strict SIG algs is another requirement that is a fallout of the FIPS 140-3, where SHA-1 cannot be used. So we'll see later that SHA-1 is gone from DB2 for TLS, except it can be still used for root certificates because they tend to lag behind quite a bit compared to your server-side certificates, that they still would be allowed to use SHA-1 unless you're using strict FIPS mode. We enable this strict SIG-algs checking, and it requires that all certificates in the chain have to be using a signature algorithm that is SHA-256 or better. So there is the potential to break Connections, if you happen to have a root certificate that is still using SHA-1 and you enable the strict FIPS mode. Okay, but it is supported. Everything works fine for FIPS and no FIPS mode. Server encrypt is blocked in strict FIPS mode. Server encrypt is a deprecated authentication type in version 12. It uses DES by default, really old algorithm. Can be alternatively configured to use AES, but even there, the Diffie-Hellman key size that we use is too small for the FIPS standard. So the deprecation statement is really about no enhancements. We don't plan to increase the key sizes to make it compliant with the current standards. TLS is really the strategic direction for client-server encryption, and that's what we would recommend being used. So, again, this is one of those cases in FIPS and no FIPS, we're not going to break functionality, and any existing stuff, even if it's not up to the current standard, we will allow use of, but strict FIPS disables it. And basically the exact same thing for the encrypt scalar functions. So this is just a quick summary. You can consult later about what works and doesn't work in FIPS, strict FIPS and no FIPS modes. Okay, discontinuations in version 12, things that are basically completely gone. So TLS version 1.0 and 1.1 are removed. They're old, they're insecure, and the industry everywhere is like rapidly removing them from your web browsers, that sort of thing. TLS version 1.2 and 1.3 are both enabled by default at the client and server in version 12. TLS version 1.2 has been supported for forever at this point. It seems like quite a long time. This is the versions where it was introduced so long ago for ZOS, the system that supported it. It's out of support now. So hopefully everybody is running at a level that supports at least TLS version 1.2. That nobody will notice these being removed. SHA-1, as I mentioned, is no longer used for digital signatures within TLS. We do not support it at all for endpoint certificates for the server. You will need to recreate your server certificates if you happen to be using it. It's unlikely, but it is possible. And then as we discussed, the strict FIPS also removes support for root certificates using SHA-1. Triple DES for native encryption has been discontinued. We've always supported both triple DES and AES for native encryption, so this likely has very little impact because most people chose AES when creating their encrypted database and backups. But triple DES is it's no longer considered secure and should not be used. But rest assured that your data is still accessible, that even though it's discontinued for creating new databases and new backups. We will full support for decrypting and accessing existing databases. So you can activate your existing database that's using triple DES. You can restore from a backup that was using triple DES. That sort of thing. That's still fully supported. Okay, what is not supported is creating a new database or trying to create a new backup that is using triple DES. Okay, so it would be best if you were using triple DES to migrate your database to AES, but it's not absolutely required right now. You can still continue to run. You'll just have to make sure any of your backups that you're creating have been switched to AES. Although you can still always restore your old backups. So data encrypt authentication has been removed. This is a client server encryption technology that we had. It's out of date. It's not using the latest encryption algorithms. And again, TLS is the strategic direction and is what everyone should be using to secure their connections between client and server. So this one has been removed. Client authentication as well has been removed. People often, I found, used it not realizing the security risk that it has. It's basically saying, trust the client to do the authentication and just tell the server who the user is. In a very, very secure network, I guess that could be fine. If all the machines are secure, nobody can add something to the network, but all it takes is someone with a laptop plugging into your network and creating a local user on their machine for which they know the password that matches the sysadmin user or dbadmin user at your database server. And then they're able to connect because they know the password, because it's at the client, which is their own laptop. Too often people just don't really realize that, use client authentication because it seems really easy, and have left themselves vulnerable. So by default, it's gone. There may be use cases that it's absolutely required. So there is a registry variable that can turn it back on, but we'd really recommend that you do not do so. This page is so minor, we're gonna skip it and you can read it on your own. Okay, I'm just going to take a quick break there before we get into the new stuff for Mod 2, just to see if there's any questions about all of those changes or discontinuations. So Mohan, do you have any questions?
Hi, Greg. No, I don't see any questions, but I do have one.
Okay, sure.
When the customer is using data_encrypt authentication mechanism, right, which is deprecated,
yep.
But
well, it's discontinued now in version 12.
Right.
Yes.
Oh, completely discontinued in 11.5 in 12.
It's deprecated in 11.5 and discontinued in version 12.
12. Okay. So they are still on 11.5, for example, and then want to implement TLS along with it as a sidecar scenario. When I say sidecar, they want to have both TLS and the regular TCP traffic with the data_encrypt to run. What is the way forward to get that working? I don't think they're mutually compatible.
They are. You can run both at the same time.
Mm-hmm.
Like you can certainly have a connection that's using data encrypt and TLS. They're at different layers. One is at the DB2 layer. One is at your networking layer, essentially. So I think your question was are they trying to migrate to TLS or?
Yeah, migrate to TLS before that one and run both together, the TCP as well as TLS connection. Right, TLS will be with a different port number and TCP will run with an existing port number.
Yeah, so you can certainly, we support running with both TLS and TCP/IP.
But my question is about the data_encrypt. Is that compatible for TLS as well?
Right, so on 11.5, they could have their authentication be data encrypt and then have both TLS and non-TLS connections work with it.
Okay.
Like it's totally, data encrypt is totally independent of TLS. You're gonna have more performance issues because you're doing double the amount of encryption,
mm-hmm.
right? But there's no technical limitation that it'll work just fine. So they could slowly start to get rid of those. I'm trying to think. Probably move the connections from TCP/IP with data encrypt to TLS with data encrypt. Once they get everything set up with TLS, they could stop using data encrypt and just switch to like server authentication.
Right.
And that would be fine.
Okay, cool. Thank you.
Yep. Yeah, no, that'll work just fine to do that. So.
Great.
Yep.
I don't see any questions at this point.
Sure, and I guess I should just mention one other thing. I think it was Mod 1, we added updates to MonGet connection so that you can see who's using TLS and what versions they're using.
Exactly.
So that it does help you isolate and find which of my clients have I not switched over to TLS yet, and go be able to change those and easily identify which applications it is. And same for if you're moving from TLS 1.2 to 1.3, which versions are they using, so you can go address those as well. So
Got it.
yep. Okay, so let's go on to mod 2 and some of the new features there. And as Mohan originally mentioned, one of the big ones is the masking behavior updates and new functionality that we have there. So if you look at the existing column masking feature that DB2 has, it's part of our RCAC feature, RCAC, row and column access control feature. There's a column masking where you can, control what values the client gets to see depending on some custom SQL that you get to write. So the design of that was deliberately chosen not to break applications. When it was first introduced, and I think it was version 10.1, a goal was, okay, let's have applications work exactly the way they do today as much as possible, and just give them some masked data as part of their output. Okay, so you ran your SQL statement, DB2 computed it, got the final result set, and then just right when we were about to return that data back to the client, we would mask it, okay? And it's what we call like the outermost select part of your SQL query. And so it did not affect earlier parts of the query, such as group by, your where predicates, joins, ordering. All of that was computed on unmasked data, okay? And that was great. Your application, if it was the one controlling all of the SQL, it worked really well. But this design sort of introduced an inference problem. So if somebody can sit there and execute arbitrary SQL, they can run SQL that can try and get around the masking. Okay, so a simple example is if you take the employee table, from the sample database, and I just said select name and salary from that employee table where the salary is greater than, say, $1 million, okay? The salary I get back is masked, but and that's where, let's assume the mask was on the salary column. The names I get back are not masked, and everybody listed there would be making more than $1 million. And suddenly I can find out, what few people maybe in a company are making a really high salary or something like that, right? So you're not getting the exact salary from this particular query, but you're still inferring values of what it was, okay? You could sit there maybe if you put an equal sign and, you could go one by one and issue the queries, okay, where it's $1 million, where it's $1,001, issue a lot of statements, and you could get exact values that way. So, this inference, it's a downside where average users have access, like when I say average, we'll say, sort of somewhat untrusted users have direct access to the database and can issue arbitrary SQL. When it's your application and everything is controlled and only certain types of queries can be issued through the application, then that design of masking makes sense. But the way it is, it just doesn't work for a number of customers who have use cases where users are issuing arbitrary SQL and really need to be masking at a much more sort of granular level. So we have introduced some new behaviors for our masking. And basically we're using the term at result to be the current style of mask. So we're introducing that as the default on the create mask statement. So if you issue it today, nothing changes, you still get the current behavior. But we've put in this at read behavior and also some restrict options. And the at read says masking should happen prior to any user portion of the statement, essentially as we read data from the disk or buffer pools, okay? And the restrict says certain types of SQL are going to return errors, that they should be restricted from usage, okay? So we're going to go into detail about what those look like. So we'll start with the @read behavior. So as I said, this is before any really user operation happens. So it's going to apply the mask before your where clause gets evaluated, before having in, join, order by, group by, before any of these type of operations are performed, the data will be masked. Okay, so if that user issued the same query as before, so they're going to select the name and the salary, where the salary is greater than $1 million, if you were just masking for this particular user, they're not allowed to see the salary, everything gets masked to 0, then this query is not going to return any rows, because the salary greater than $1 million, well, you don't get to see the salary now, and well, you do get to see the salary, but just every value has it's a value of 0, so it's never greater than $1 million. If you were to say return a random number for the salary, then the results they get back are meaningless because it's not a true value. Okay, so this essentially almost completely gets rid of the inference problem, and almost completely, we'll talk about that in a minute, but it really solves the problem, but it introduces a potentially very big performance impact, right? Because that masking happens so early that DB2 might need to start just doing table scans in order to be able to, mask everything in order to give you the result, right? So if previously you had an index on the salary, in this example, that doesn't necessarily help anymore, because now your query really is transformed into the mask of the salary, okay? So you might be able to use index on expressions in certain cases to help that, right? To now index on what the actual query is executing, which is the mask of the salary. It depends on what your mask is, right? And whether it's uniqueness preserving, that sort of thing. So this is really primarily aimed at cases where the masked column is not used in any operation of your SQL. It is only being returned as a select column. Okay, so that if you're doing a group by a masked column, it suddenly doesn't make any sense anymore, because you're just masking by who knows what the mask is, right? Ordering by it, joining on it, all these sort of conditions suddenly they don't make a lot of sense, and if you do them, could have very big performance impacts. Okay, so it's really going to solve the problem where you're just doing select the masked column, and then the rest of your SQL query is not referencing that masked column anymore. Then it'll perform as it does today. And that was really the use case that a number of customers that came to us with, saying, look, it's okay to behave that way because we're really only referencing those columns in the select statement and not, or sorry, in like the select column list and not in the rest of the query. So sounds great, solved an inference problem, but be really aware of performance problems that can result from it, right? Because that masking is happening just right away. There's also the restrict usage that we've introduced, and this basically is going to return an SQL error statement 20478 with a reason code of 42 whenever a masked column is used in a number of scenarios, basically anywhere that inference is a problem. Okay, so where clause is having join conditions in, order by. So if we go back to this previous statement that had a problem where salary was greater than $1 million and salary has a mask on it, and your mask says restrict usage, that statement's going to get an error. You can't compile it because basically you can infer data from it. Okay, so there's just a number of other cases. OLAP functions that include order by. So anything doing an order by is a problem. Aggregation functions, set operators, union, accept all, intersect, and intersect all can let you infer data. The only one missing from there is union all. So the restrict is saying, hey, don't let people even issue these type of queries. Now we have one condition that can help relax that restriction a little bit, which is the allow joins option. And it says, we will allow a join on a masked column, but under some specific conditions. It is a bare reference to the column. So you're just saying join like table1.c1 equals table2.c1. Okay, there's no other expression around that. And the other side that you're joining against is a bare reference, and it also has a mask on it. So if t1.c1 is masked and your join is t1.c1 equals t2.c2, then that t2 dot c2 or c1, that other tables column also has to have a mask on it as well. And this prevents problems against common table expressions where you're sort of dynamically creating a table. It has to be like a real table that has a mask on it that you're joining against. So if under those conditions and you've specified it, you can allow the join to happen. So the restrict usage, it depends what type of masking semantic you have. So for at result, it's really targeting preventing the inference scenarios, right? So you're saying, hey, I like this at result type of masking that I don't have to worry about the performance problems necessarily, but if there's any of these scenarios that can have inference, just return a SQL error. And for at read, because it essentially, we'll say, solves the inference problem, you don't need to do this restricted usage, except it can help prevent the performance problems, right? So, things like those group buys. Well, it doesn't make sense to do the group buy on the mask at read. So if you did the restrict usage, you could just be, saving yourself from users issuing those type of queries, okay? One other thing, when I said before that it almost solves the inference problem, and that is if you're going to use uniqueness preserving masks. And what I mean by that is, some people just want a mask to like null or zero, right? They're like, you either get to see it or you don't get to see it, and you're not getting a special value, you're just going to get null if it's masked for you. That's not a uniqueness preserving mask. Some customers have use cases where they want to give back a value for, say, a salary. They don't want it to be the actual salary, but they do want it to be unique in the sense that it's different from everybody else's, or something like that. It's not everybody has just the same salary of zero. It's everybody has a different salary. So if in that case, if you have a uniqueness preserving mask, someone could still come along and say, well, show me the name and salary where the salary equals. And if they can call the mask function, they can get back the results then the same as they originally could, because now they're just saying, show me everyone where the mask of the salary equals the mask of $1 million. And so they may be able to infer data. So you may have to restrict how someone can call the masking to make it so that they don't really know how it's essentially how it works, and be able to call it directly in their SQL statement. So, and I was careful to say before that the mask at read semantics is really masking before the user portions of the SQL statement, like the group by and that sort of thing. Masking still does not apply as today to the non-statement internal DB2 operations. So, for example, maintaining referential integrity, population of MQTs, trigger transition variables, that sort of thing, that those are still going to see the unmasked data. Okay, so it's really just the SQL portions that that the mask applies to. So, you know, that's one of the exciting new features that hopefully is going to solve some use cases for customers. That you know, it's not perfect because masking, you know, really it's a difficult thing in terms of how it affects SQL operations. So we sort of have the one current behavior extreme, I'll say, which is you know, only mask on the output, and then the other end of the spectrum where is masking as soon as we see the data, and you know, can only be used, we'll say, in limited scenarios. But you know, if those limited scenarios really work for you, then it's kind of the ideal solution. Okay, another big change in Mod 2 that we've done is addressing insecure file permissions. So specifically for world writable file permissions within the instance. So lots of customers have security scans that run on the systems that say, hey, you've got a world writable file, generally not a good thing, and you know, customers have to get exceptions for it from their security teams, that sort of thing. So we're taking steps to address that. And so when I say world writable, I'm really talking about, so this is a Unix specific feature for Linux and AIX that if you look at your typical, if you do an ls output and you see, or ls-l, you see the permissions, read, write, execute for user, group, and other. We're talking about the other permissions, right? And so the last three for the read, write, and execute, and specifically it's that last W, right, for write. When that is present, basically means anybody on the system can write to the file. And you know, there's very few DB2 files that have that, and generally you can't get up to too much trouble, but it's still a concern for customers. And the reason we really have that is just the sort of embedded client DB2 has with the server, where there's a server, but there's also a client that is part of it, and we allow multiple users to actually reference that client. And so you can install just the DB2 server that includes the client, say on a Linux server, and have local users. They don't need their own client. They can actually source the SQL lib from that install, from that instance for the server, and have it act as their client. So there's those use cases, as well as the DB2, the defense mode process running as a separate user. We have all of these cases where you can have different users other than the instance owner trying to read and to write to some common files. The most common one is the db2diag.log, right? So we want all of those users that might be accessing that instance to be able to log potential issues to that file. And so the db2diag.log file is world writable. What we've come up with as a solution for this is that we're creating a local, or well, we're not creating it, the customer's going to have to create it, but the concept of a shared group file. This is really analogous to the DB2 users group if you've used the Windows Extended Security, and it's a group that any user who wants to interact, or that you want to interact with DB2 must be a member of this group. So this would be the instance owner, the fenced ID and any other local users, like administrators, that are using this instance. So you have to create this group and add the people to it. It must be different than the instance owner's primary group. And then you basically tell DB2, hey, I want to use this as my shared group for file permissions. Okay, so there's just a number of different ways that you can turn this feature on. When you're creating an instance, you would specify like db2 create with the existing options with a dash shared group, okay? And the group name, or you can put a dash no shared group that you don't want to use it. So you're telling, db2 when creating this instance, what would have been world writable files should now be owned and writable by this shared group. Okay, so for example, the db2 would now have the group ownership of the shared group and be writable by the shared group, but not by others. Okay, so that you're now getting rid of that world writable permission. db2 update for an existing instance can be run. Right now, it has to be done offline. You should be doing a db2 stop, updating your instance with this. Actually, you need to update to version mod 2 first, and then as a separate step, turn on this feature. Something we're looking at improvements for to sort of be one step in the future, but right now it is upgrade to mod 2. You'll have to take an outage, stop, enable the shared group. And similarly for PureScale, if you want to turn this on right now, you have to do db2 stop on all members. That we didn't want to be changing file permissions at the operating system level underneath db2 while it was still running. So it does mean to turn this on that you needed to totally stop the instance. Okay. Just some other ways, it's supported for non-root as well. So you can do the non-root update to turn this on to tell us the shared group, and client side as well. So if you have just a pure client, you can turn the feature on as well. Okay. We will actually, so if you're updating an existing instance, we will go through the common db2 files and change the permissions for you so that they do get updated. So it's not just new files, it's the existing files will have their permissions changed. So currently in mod 2, it is specific to world writable. That has been like, the most worrisome for our customers. We do get requests for world readable, something we're thinking about, but don't have an announcement at the current time for that. So just to distinguish the two between the world readable and the world writable. And Mohan, I think that, oh no, one last slide. I was gonna say that's it, but I forgot about some of the audit improvements that we've done. So you can now audit directly to COS, to Cloud Object Storage. It is the binary file that we write. So it's in replace of it, basically the archive statement that you run now, that you do not need to do the archive anymore. We're going to write directly to COS instead of a local disk. You configure the data path with the remote storage alias. So this is the same remote storage alias that you'd use for writing to Cloud Object Storage for your backups or to be able to load from, that sort of thing. That's that same infrastructure. And you just tell us that alias for your bucket, and we will write to it. So right now it is still the binary file that we write, which is it's a DB2 proprietary file that has the audit logs in it. You'll still need to download them and extract from them to get them into like a CSV file or the report file that we have. So to make use of it, you still have to grab them and look at them from COS, but it saves you that step of writing locally, then trying to upload separately. So, again, one of those areas, looking in the future for potential improvements to that, but it's sort of the first step that we can now write directly to Cloud Object Storage. It's actually something that's been used by our cloud team for a little while now in their latest audit support that we're bringing, to on-prem. The other thing is some improved resiliency around the audit log if DB2 were to trap. That we've made some enhancement that if you're buffering the audit log in memory, that we make sure that is actually now written out to the archive path during our trap handler. So if DB2 does crash, we dump a lot of diagnostics and extra information. One of the things is making sure that there's sort of a separate area that we write out those in-memory audit logs that we had not written to disk yet, so that they're there. And if you are auditing directly to COS, we will actually upload them automatically the next time DB2 starts. That you don't have to worry about it. We'll get them up there. So it really helps. Unfortunately, there are cases where DB2 does trap. It's not often, but it happens, and this will improve the resilience of those log files. So, okay. That officially is it, Mohan. A whirlwind tour of everything we do.
Yeah, one question about the audit DB2 remote capability with the DB2 remote clause, right? So where we can write directly to S3 bucket.
Yes.
Let's assume if my HADR, my primary and the standby, if my my standby becomes primary, can it write to the same location? Does it resume from the point it left off? Or it's going to write the new file? It should be.
Okay, so for HADR, the audit is configured. The data path is configured at the instance level and is something outside of HADR. So you're going to have to make that change initially at both systems.
Right.
Okay. So that you're going to have to go to both and run the DB2 audit configure command at both places to tell them and you actually have to create the remote storage alias at both systems.
Right.
Okay. So you've got to do that and tell it audit to say, hey, here's where you're writing. But basically, every time we're creating essentially a new file all the time for audit. When we're writing to COS. So that's going to be when you fail over, it's just going to start creating a totally separate new file, right? So
okay.
When you're writing to local disk, we basically we're always opening and appending to an existing file, right? The db2 audit.log file essentially. And it's when you run the archive command that we take that file and we archive it off for usage that you can extract from it and start writing sort of to a new file. And that's different for when we're writing to Cloud Object Storage. We're basically continually, because you don't really have the concept of appending to a file on Cloud Object Storage. Once you've created the file, it's done, it's there, it's static, right? So we are every once in a while basically creating a new file. And the exact logic for that has sort of changed during the mod packs. It used to be time-based, but now it's basically when your buffer gets full, you can do the DB2 audit, the audit buff size dbm config parameter. Basically, when that gets full, we're going to write a new file. And so, let's say that's 100 megabytes, then basically it's going to be a 100 megabyte file we upload to COS, and then you get a new file on COS. And they'll each be sort of 100 megabytes in size. And so we're always creating new files. And so, as soon as you fail over, it's a totally new file then on that standby system.
Oh, that's cool.
Yep.
Awesome. I'll take the screen back again.
Okay.
All right. That's great. The that concludes today's episode of DB2Night Show. A very special thanks to you. Thanks to you, Greg, Db2 Security Architect at IBM Canada Lab, for delivering such an insightful and detailed session on the security update. Thanks, Greg. Your expertise on restricted file permission, alternative masking semantics, and evolving security landscape for DB2 is invaluable. Thanks again for spending time with us today. As always, the replay and presentation material will be available within our DB2Night Show website, as well as the YouTube. This probably will be available by end of day tomorrow. And stay tuned for the upcoming sessions. Continue to bring you to the latest innovation, deep technical details, and best practices directly from the IBM Lab. Until next time, this is the DB2Night Show team signing off. Stay safe and have a good Friday. Thanks, everybody.
Thank you.
Have a good day. Bye.